Welcome to day 29. In this one, we are going to be parsing data using regular expressions, which really means just parsing data with some sort of pattern. Now, in our case, that pattern is going to be phone numbers, right? So if we actually take a look at all of these right here, these are ways you can actually format or write out a phone number in the United States. And the vast majority of people in the US will probably understand at least some of these, if not all of them. And so what we want to do is actually parse this data and treat all of these numbers almost as the same. Like they all have some sort of pattern, right? They all have, at least they have these 10 digits, right? In some cases, they have that 11th digit. Some of them have dashes, some of them have parentheses. But in general, they have roughly the same amount of digits and roughly the same pattern. But that rough part is actually a bit challenging when it comes to using sort of traditional ways of parsing data in Python. And before we get into the code, I want to mention this guide. The link is in the description below, and I'm going to be referencing a number of things in this guide throughout this video, but I really want this to be a reference for you going forward as you use regular expressions. Now, regular expressions themselves, well, they're a bit tricky to build a mental map about. And the reason for that is because it's not always that practical to use a regular expression if you don't fully understand it, right? Like doing a for loop is almost always practical because you almost always understand how to do it. But that doesn't always mean that it's effective or efficient even. So regular expressions are a much more efficient way to parse out data, which we'll see a lot throughout this one. But the mental model or the mental map that you're trying to make of like how to use these regular expressions, for me at least, was rather confusing. So this guide hopefully will be your guide to really mastering regular expressions because they are incredibly powerful. And once you understand them, it's just like very freeing. Phone numbers are a perfect example of what we would need regular expressions for, because the way they're written is often very different, but the actual way they're used is often identical, right? You just type in the numbers on a phone in a sequence, and that will actually call that number. But for whatever reason, we never actually created a truly standard format that everyone uses around the world, as denoted right here. Right? And I don't know if that will ever change. It probably won't. So let's actually see how we're going to go ahead and parse out any given phone number. So I'm going to start with a really basic one. This one is a very common format in the United States, is to write it in this way. So we're going to stick with that. Now, using basic Python to parse out only the digits here, you could do something like this. And this is just a for loop that has a character, right, that we try to turn into an integer. And then once that's done, it just appends it to this list. And then we combine that list all into one string itself. Now, the idea behind this is really simple, but it's not incredibly efficient. I would say beginners would probably jump here. Maybe with the exception of this list comprehension down here, because realistically, to join a string, each item has to be a string. So if that's not a string, this is going to be an error. But that is a very baseline intuition of actually going through these numbers. Another one, and perhaps a little bit more of an advanced user, would jump to something like this, right? That's still certainly not that advanced because it does fall apart with, some of these other digits as well, right? So if there's a parentheses or a plus there, that's not going to give me all of those digits. So it's not perfect. I mean, it works for this example, but it's certainly not perfect. Now, another example would be this right here, where this, of course, is a list comprehension again, but the main thing is this condition right here, which on any given string, you can type is digit, and it will give you a Boolean value whether or not something is a digit. So a good example of that is this string right here. If we just type out is digit, it should give me false. But if I get rid of the dashes, it gives me true. Okay, so we can totally use that to our advantage with extracting any of these out. right? So it actually would extract those strings or those numbers out into something like that. So that is the traditional way, or the least efficient way, to actually pull out these digits. Regular expressions makes it incredibly easy. So we import RE, and then we declare a pattern of some kind. Now, just bear with me on the pattern itself, but it's just /d. And what we often want to do is denote it with an R in front of this, denoting regular expression, but it will work just as a normal string. Just make sure that you're using /d and not just d. So /d or \d, and then we use re.findAll, and then we pass in the pattern itself, and then we pass in a string that we're trying to parse. In this case, it's simply my phone number. And if I hit enter here, I get a list of individual digits. And the reason that they're individual digits has everything to do with this pattern here. So if I actually want to group the digits together as they are grouped up here, what I can do is append this pattern just a little bit with a plus. That plus is going to say, hey, if there's repeating digits in here, group those together. As soon as the repeating digits stop the pattern match, right? And then move to the next one. That's what the find all is for. So there are certainly other kinds of regular expressions in here that we can do. Something like re.match is another one. We will cover some other kinds of regular expression functions in the later part of this one. But for now, we're going to just stick with find all. Okay, so that's a very fast and simple way to actually find a regular expression or use a regular expression to find the digits that we wanted. Now, of course, I could still concatenate them and make them one long string if I wanted to, but we're going to stick with this pattern just a little bit more. So sticking with this example, we can actually apply this to other strings as well. Right, so here is a simple string with two different sets of digits. And we see that the pattern of these phone numbers is just slightly different, right? The actual formatted pattern of them. So again, we can use the same regular expression pattern. And we just pass in our new string here. Hit run. And now it actually parses these things out. Now, the rhyme and reason to them is still a bit tricky. We'll discuss that once we get there, but it is absolutely only parsing out these phone numbers, right? This is really cool, but it's starting to get hard to distinguish where does one phone number begin and where does the other one end. And that's actually the pattern we want to work towards. So for now, we're going to stick with this, but highlight one more example as to where these simple patterns fall short, or where it starts to get kind of challenging just using regular expressions. So here's another example. This now has, of course, other kinds of numbers in here. And again, this will create another problem with distinguishing which one's the phone number and which one's not, right? So if we come in here and take a look, we get this response back. Now, if I wasn't using D+, now it's incredibly hard to decide which one's a phone number and which one's not, right? So that is why we actually need to learn how to write better patterns. So how do we actually combine patterns together to make a much bigger pattern to better fit what our phone number formats could potentially be? Let's take a look at a little bit more of an advanced example. So if we look here, what we've got is that same meeting string, and we have a brand new pattern that might look a little scary, but we'll break it down. And of course, that actually gives us the result we're looking for. It actually extracts that entire phone number, including the +1, because we actually do want to have the +1 if it's there. And so now that we've got that, let's actually break this down into smaller parts. But before I do, I want to bring attention to this \+. Now, we've already seen a plus before, and that's up here. When we do \D+, what that is doing is it's grouping together every digit as long as the digit is next, right? So in other words, if I used /D, remember it goes into all of the digits. As soon as I use a plus, what it's going to do is it's going to look at every single character, And then when it finds a digit, boom, we've got one. If the next one's a digit, those two are together. If the next one's a digit, that one's together. And then as soon as another non-digit comes out, it breaks that group. A good example of this is if we type out a bunch of random digits and use a colon and then run this again, we see that it actually breaks that apart and ignores the colon altogether, but actually groups those numbers correct, right? And that character can be anything. It doesn't have to be a colon. It could literally be anything that's not a number, right? So that's really important when we're using these pluses inside of our patterns. But what's happening here? Well, this backslash is actually escaping that plus. Now, you already are likely familiar to the new line call inside of Python. The /n creates a new line. This is basically just saying, hey, regular expression pattern using a plus in this pattern is okay. So since we are using a plus in this pattern, that means it's going to find all of the instances with that plus in it, right? So if I actually paste that same number again without the plus and run this, I do not get that number, right? It actually doesn't show it at all. Now, of course, if I got rid of that /plus and then ran it, I get both of those numbers. The plus is gone, right? So if I want to actually use a plus in that parsing, we use /plus. Now, this actually is evident of a bigger concept that we'll talk about with regular expressions later, but it is something that we should know about right out the gates. And that is that certain characters need to be escaped like this, and certain characters do not, like the dash, right? So the dash actually, we didn't have to write /dash. It still works, but we don't actually have to escape it. So that's also another critical piece of that. Okay, so what does this look like then? Let's actually break down each part of any given chunk. So we'll say this chunk right here. I'm going to go ahead and put this in here. So again, we see that /plus escapes the plus, so we can use it in our pattern or the actual matching, right? And then /d matches all digits. We've seen that already. These curly braces and 1, this is something brand new. All that's saying is whatever this matches, or excuse me, whatever the preceding thing matches, so the /d, just make sure it's this long. That's 1 long, or 3 long, or 3 long, or 4 long, right? So if I change this pattern to being 5 at the end, no pattern is matched. If I change it to 2, hey, a pattern is matched, but it actually cut off 2 of those digits at the end, right? So of course it needs to be 4. And that's the general idea of these curly braces. It's really cool. So now we can actually see how do we actually get matching digits that are only 1 long, and that's just a simple way to do it, or in number of long. So that's with those curly braces. And then the dash, is there a dash? Yes, we already talked about that. Okay, so the next thing is to better understand any given pattern. What I personally like to do is to break it up into chunks that I for sure understand. So the chunks that I decided are these, right? You could chunk it even more than this, chunk it down all the way you need to really fully understand how this actually works. But of course, we can break this down even further again, and we see that this first chunk, all that it's doing is looking for a pattern that starts with a plus, and then the next actual item is a digit. It would continue to look for digits depending on how long this is. Now, this curly braces 1 is in contrast to this plus, right? So that plus will keep going as long as there's a group, where the curly braces and whatever number's in there is only going to go the length of whatever that number it is. Okay, so let's go ahead and see that pattern again. I'm going to go ahead and copy this, and I'm just going to use the chunk 1 for this. So chunk 1, and again, I'll get rid of all of these other chunks and run this. And let's go ahead and use chunk 1 as our find all pattern. And there we go. So we now see that chunk 1 is in there. If I get rid of that dash, we get 1. And if I get rid of that plus, well, now I get all of the numbers, literally all of the numbers, right? And that's where the designation of having a start here makes a huge difference, right? So it's looking for every single number that starts with this plus. So that's that first chunk. Now I'll let you go ahead and do the other 3 chunks. The first chunk I think is the most complicated, only because it has that plus. something we haven't seen before. Now, if I use any other digits here, it's going to look for something. In this case, I got an error with a star. So the star is another thing that we need to escape inside of a pattern. This is not at any way related to what's in the string. The string itself can have the normal Python string stuff, but the regular expression pattern needs to have those escape patterns. And what I did here was now I'm actually using this star. So if I changed this dash to a star in here, it would now actually match what that is. So again, another thing that needs to be escaped. So there we go. We now have our chunking patterns. And this is actually how I'll write these patterns going forward. Now that we understand that we want to use chunks, let's actually turn this more complicated example into chunks. Right? So here it is, right? Each chunk is broken out, just like we had above. And now we actually have a string for this pattern. And we can actually call this pattern as a Python string in this findAll method, just like that. And again, it's giving us the exact same result as we expected. And of course, if I add a plus here, it's going to give me both of those things. The adding a plus or not having a plus is what we actually really want to talk about here. But before we go any further, I will say that oftentimes what you'll see when it's a string substitution pattern, this does not have an R in front of it. It has an F, right? So a lot of times what you'll see, and this is probably better practice, is to say a new variable equals to re.compile our regular expression pattern, right? And then you pass in whatever that regular expression pattern compiled is into that findAll method. This is not required, but it is a very, very good practice to have. The other part of this is if you do compile it, you no longer have to use re dot, and rather you can just use regular expression dot, and then get rid of that regular expression in there as well. So I will be using a lot of these things going forward, but in a lot of tutorials and a lot of questions you'll see is something a little bit closer to this pattern, maybe using a different regular expression method. But I'm going to start with here, and then we'll start to build up to using re-compile in a little bit of a different way. Okay, so the main reason that we're talking now is to have an arbitrary variable that may or may not be in this pattern, as in that plus sign or those dashes, right? So we had all of these valid numbers. Let's go ahead and grab this long one down here too. And each one of these numbers is the same. I want to actually allow my pattern to grab any of those. The coolest thing about this is there's a question mark. So a question mark makes that value optional. And I'm using these things all chunked out inside of the chunks even, just to make it even more clear as to what's going on. So this backslash plus is now optional because of that question mark. Of course, if I wanted to match a question mark, I have to escape that question mark, just like the plus. But using that question mark changes how this pattern actually looks up everything. So if I run this, I now see the original pattern now matches both of these numbers, right? Just because of that slight change with that question mark. And of course, I can add that to these dashes as well and literally just add it like that, right? Or I could just leave it in the chunk itself. You know, more often than not, you're not going to see them chunked out like this. But with this, we now see that, hey, I actually can match all of these different chunks just like that, right? And you could add additional, question marks on here. You can add different matching pieces to these chunks as well, or matching patterns. But just remember that each one of these little blocks is a pattern that is a chunk that's building towards a much bigger pattern that just looks for matches on that entire chunk. And adding that question mark means that the preceding pattern is optional. So now that we understand we can make the plus optional, we can make the dash optional, how do we actually make the parentheses optional? Now, parentheses in regular expressions serve very valuable features as well. So I'll go ahead and copy these chunks all over again. And this time I'm going to get rid of that meeting string and just use the phone number pattern itself. And we run this. We don't have a match at this point. So you might be tempted to be like, okay, well, here's the first digit. So the first chunk is this right here. Here's the second chunk and the digits themselves. I'm going to go ahead and just add in parentheses around that item. Okay. So this is the intuition that you may have. We run that, still not getting anything. Now, parentheses actually group these things together in a different way. We'll see that a lot in the future. But again, when in doubt, just escape the item. So using a backslash in front of what we're trying to escape. Now I run this. Now it actually matches that pattern, right? And we can actually use that same pattern again. Let's go ahead and break this down here. And I'll put this phone number now in that meeting string, or phone number string, really. And we run that. Now it's getting me only the one with slashes because I actually didn't make the parentheses. I didn't make them optional, right? Oops, let's go ahead and now turn this into a chunk of chunks. Okay, so we've got our parenthesis, our opening parenthesis, and our closing parenthesis. So I can make these optional again with a question mark and a question mark. Run that. Now it's giving me all of those phone numbers. All right. So that's pretty cool. So I now have optional pluses, optional dashes, and optional parentheses. Now we will be using these parentheses a lot more going forward, but the concept here is just to understand, again, that we need to escape things. So when the pattern's not matching as you might intend, chunk it down even further, run those escape calls, do the optional value, and then you'll probably see what it is that you're looking for. All right, so we now have a way to scrape all of those phone numbers, right? Literally, like we can now parse out any string with those phone numbers with these chunks. And if we take a look at the actual compiled regular expression pattern, we see something that might have been really intimidating. In fact, it still might be intimidating, but if you chunk it down, it becomes, well, incredibly understandable, I think, at least. And even if that's not incredibly understandable, if you're still having issue with it, just grab each individual chunk or each individual piece of that chunk, compile it, and then find all of those in any given string, and you'll start to see what that pattern is. Now, there is another thing that I actually want to do to these numbers. Let's say, for instance, this first set of numbers, the first three that is, I actually want them all to be odd numbers. This actually presents a new challenge. That's because right now we're just matching all digits with /d. So this is actually a new concept for us that we really just haven't been covering to this point. And the reason for that is because /d is, well, it's really easy to use. So let's take a look at what /d actually means. If we come in here, /d actually represents the list of 0 to 9, or actually brackets 0 to 9. This is not a list. It has all of those items in there, but it's not actually a Python list. This is a regular expression bracket that really covers all 0 through 9. So in other words, I can actually grab these chunks again, and we can replace every instance of /d with the brackets -0 through 9. So 0 through 9 must be in this brackets for this to work. Let's actually bring in that meeting string as well. And we see the exact same thing. And of course, if I compile it, it is definitely different and now definitely more complex than it was, or at least it seems that way. Okay. So I did say that I wanted to only have odd numbers here, right? And that's only in, or let's say the second chunk, only in the second chunk, we only want odd numbers in that value. So how do I go about doing this? Well, first and foremost, I'm going to grab our original one with the /d chunks and only change the one that I really want to match, the only one that I need, which in this case, I can use those brackets again and do 1, 3, or no commas rather, 1, 3, 5, 7, 9. Right? So those are all of the odd numbers it could possibly be. Again, it's not a list, so you don't want to put commas in there, even though that might be what your intuition is. Instead, regular expression, this actual bracket pattern is just looking for numbers in there, and the maximum amount we can have is 3. So we run that. Of course, these all still work. No surprise there. Now, if I actually change this to being positive, as in 0, or excuse me, not positive, but even 0, 2, 4, 6, 8. 0, of course, representing 10 and 20 and so on. We run that, and now it finds none of them, right? No surprise there. What about only 5? Like literally the number 5. Well, if I change it to 2, that one no longer works, right? So we can now actually come in and hone in the specific numbers that we want to use here. Now, you can also use letters, which we'll talk about more later. But the idea is that if I need a span of numbers, let's say, for instance, 3 to 7, that will encompass the number 3 and 7 and everything in between. That's a way to do it, right? Or if I want 1 to 4, right? So this is actually how we can chunk it even further based on any given number. Now, what this also means is that we can take that one step farther and come in here and use only the first digit, right? So let's say, for instance, we want this first digit to be between 0 and 2, and then the second 2 digits can be anything. So what we would do is come in here and say 0 to 2, and then we copy this same block. In this case, I'm going to add another chunk here and say 2, and now this one is 0 to 9. Now that matches only that regular expression, or only that value. Okay, so again, the D is matching all numbers. If we want to break it down to specific numbers, we can write what those specific numbers are, right? There's no shortcut that I know of that's just for even numbers. You actually have to write out the even numbers, or a shortcut for odd numbers. You have to write out all of the odd numbers that you want to match. And then we actually repeat it over and over, right? So in this case, 1 through 4 is going to give us a spread or a range of values that it could possibly match. And then finally, if we want to only get one digit in a 3-digit group, we can just explicitly say, hey, that first digit, check that, and then the other 2 can be that, right? So this is going to match something that's 1 digit long, and this will match something that's 2 digits long. They just happen to be right next to each other. And again, if we look at this pattern, you're going to be like, oh my gosh, that is starting to get really complicated. But then break it into chunks, it's just not nearly as complicated. So I think that's pretty cool. The other part is, well, what if we want to match specific numbers, right? So what if I want specific area codes? So now I want to match specific area codes, and you might not be familiar with what area codes are, so I'll just lay it out real quick. This right here is the country code. This is an area code. This is called the exchange code, and this is called the line number. So chunk 2 is the area code. So let's go ahead and grab specific ones, and I'm using the original chunks that we had before. We went into more specifics, and I want to just change chunk 2 because that's what I'm calling my area code. So inside of chunk 2, I can actually get rid of the digit matcher and use parentheses, question mark, colon. Now, we're not going to actually talk about this a whole lot other than the fact that we can now type in 213 or 212, right? So that actually gives me 2 different kinds of area codes specifically for that chunk. So if I run this, I get nothing matching. And of course, if I change one of these numbers to match in that, that is actually how it's done. So you can totally do it to something different as well. So like ABC and 212 rather, and we can use ABC, and there it goes. It actually matches what that value is. Of course, if I use a capital A, it does not, right? So we'd actually have to put in a capital A. We'll talk about numbers more, or letters more later, but for now, we'll stick with those numbers and just understand that this slash right here, that pipe, is the OR operator. And we can actually use another one like, 909 Riverside. I don't know why that came to mind, but 909, and there we go. We run that. There it is, right? So we actually have a way to use OR numbers, or in this case, OR area codes that would actually run through that. And of course, you can use the same concept again for just individual numbers or the starting number. If for some reason you wanted to use an OR condition, you can absolutely use something like this instead of the actual number explicit that we did there. And then you can add in the length of /d and 2, and then that will give you very similar type results, where this just putting it in parentheses with the question mark and the colon, and then the actual OR block we want to use. If you actually forget and you try to do something like this, that's not going to work as you might anticipate. And of course, if we actually just put it in like that, it does something funky for us. So what we really need is to use that format right there with whatever our OR block is inside of that. And that OR block is the literal value of those things. So like we saw with ABC, 1, 2, 3, we can use plus, right? But not really, because just like with everything else, we would need to actually escape that if for some reason we did have plus. So that's only for that one single block right there, not for the other ones. So the OR block, I think, gets a little confusing, but the main thing is to just understand that, yeah, we can also put in specific numbers that we want to consider one or the other, and not necessarily all numbers, or not just like a list or a range of numbers as well. Now, up until this point, we've been using the concept of chunks to make up our greater pattern. Now what we're going to do is take that concept and build upon it and call it groups. Because what we're really trying to do here is understand what's happening, or what the group is that's related to any given chunk. As in, this first chunk has one specific number that we're after. The plus is optional, the dash is optional, but that one single number is the thing that I definitely want to have, and it is assigned to some sort of group. So with phone numbers, the groups are well understood around the world. Even if you don't know these terms, just understand that, yeah, there's a specific pattern that all phone numbers have been set up as. Websites aren't any different. There's a specific pattern for websites. So if we look at groups here, we've got country code to start, area code, exchange code, line number, and so on. Right? So that actually gives us this value. So going back to a very basic example of those chunks, we can see this is actually how we compile all that. And what we want to do is actually convert these chunks into groups. So how do we actually go about doing that? Well, what we do is we say group 1 instead of chunk 1, and then we put parentheses, not escaped, but just regular parentheses around that chunk. That is now our new group. And we can repeat this process for all of these groups. In fact, I'm actually going to go ahead and copy the example from what we have online or on that blog post. But the idea is this stuff shouldn't be anything new other than the fact that we are putting those parentheses there. And now you can compile it. Remember how I said we're going to be using this more? This is how it's being done. And then we look for a match. You can still use find all, but match gives us other kinds of features that we don't have with find all. The features being the group itself and the subgroups that are in there. So if we run this, we now see what I mean by that with these different groups. The entire group, or that matching pattern, which is what find all gets us, is that entire thing, right? It's just that whole pattern. Each chunk is become a group itself, and here they are, right? So if we actually put a plus here, we actually have a none type attribute has group, right? So in other words, if it's matched, then we can actually run that group method, right? So before we would find all and it would give us an empty list if there's no match. With using match, then it absolutely has to find that. And of course, in this case, I could just use that plus question mark, and there we go. adding that to our group brings back that robustness for having the plus and no plus, right? So if we actually used this same group pattern in a find all method, we would still get very similar example, or still get the same sort of idea here, that group pattern of that example. But this time it's actually into the group tuple, and it is in a list, right? So it's not necessarily giving us that entire matched item. But if we had multiple ones, multiple matched items, they would be tuple or tuple in there as well, right? So it's just going to be a list like that, which is totally fine. And that has everything to do with the fact that we are using those parentheses. So the reason that we use groups then is really to be able to actually assign them to what their group really represents, right? So country code is going to be that first group, that first iteration. And to actually grab the groups themselves, well, what we can do is we can use matched and the index of any given group. So let's say, for instance, match 0. What that actually gives me, let's comment out this. Match 0 gives me the entire group, and then the length of the amount of groups, as in I have 4 different groups in here, as denoted by each chunk with those parentheses around it. This actually can go up to 0 plus 4, so it can go up to 4, right? So normally a list of iterables wouldn't necessarily have that, but the idea is we would have position 0 of this one is going to be the actual entire group, and then n plus 1 and so on is related to the n is equal to the number of groups that are actually in that entire pattern. This, again, will be something that you'll want to play around with, but the general idea for these groups is that you can chunk together our regular expression into groups that are a lot easier to identify what group they belong to. And this is incredibly important for our phone numbers for sure, but also in websites. Like, let's say, for instance, you want to get the domain name, for example, from a website, right? So that is actually a group. So https www.cfe.sh, right? So this is a group. Even just the domain itself is a group, or the and then the subdomain, and then the protocol. All of those things are different groups of this entire pattern, and being able to actually group our regular expressions is really important for even websites in that case. That gets a little bit off track there a little bit, but now what we want to do is actually see these groups as parse.values. Now I actually already did this, so I'm just going to copy and paste it. And now we can see that index thing that I was talking about right here as, you know, as it's brought out. So match group.1. You can grab group 1 there, or you can grab index value 1, because group 1 is the same thing as using the index value of 1. That will give you the exact same value overall. Whereas if you did group 0, it's going to give you the entire group, right? Cool. There we go. So this now is actually how I could then turn all of this data into a spreadsheet, right? But there's actually a little bit more of a robust way to write this, and that's something called named groups. Named groups work almost identical to regular groups in the fact that we actually put parentheses around them, right? But we also use a question mark P, and then angled brackets, and then a keyword name that we want to have. So country code would be a good example for the first one. And the second one, again, parentheses, question mark P, angled brackets, the keyword that we want to give, like area code or region code. I think that's another way to put that. And then close it off with parentheses. Now, something I didn't do above, which was the actual arbitrary values that we may or may not want to have, like these dashes. The main thing that I actually want to have is the values that are not related to those dashes. So I'm going to go ahead and remove that from the parentheses. That also allows me to have the, plus in front and maybe even an optional dash as well. And again, if you don't remember how these things work, you can always just separate them out into their own chunks, because the main thing that I want to know about is the country code itself. And then the next one would be the region code, the actual number itself, not the dash and anything that's related to that. So the region code, the other part of this was, using those other parentheses, which we have to escape out, because now we know that parentheses themselves are actually responsible for creating groups inside of these regular expressions. So the next thing is actually adding the closed off one. And there we go. So now we have a little bit more robust of chunks, and I'll go ahead and use probably the most complicated phone number you would have on here. Possibly not even in the correct format, but now we've got all these chunks, this new pattern. Notice that chunk 1, 2, and 3, and 4 aren't necessarily named. You can leave them that way. I'm not going to leave them that way. Instead, I'm just going to go ahead and copy and paste what their values will be from the blog post. And the blog post goes in a little bit different of a way than this, but the general idea is still there of these named groups. So we run through there, and now we still have find all here, right? It's not actually giving me the matches, but it is giving me all of the groups themselves, which is pretty cool. So what I can also do is actually grab any given match based off of this list as well. So what I can actually run in here is say find iter, and what that does is gives me an iterable object. So this iterable object I can actually run through. So let's go ahead and do for m in those iterable object, and I can print out m.groupDict. And what that does is it actually runs through all of this string here, or however long that string is, and then it gives me access to the matched object itself. Much like what we saw up here with these matches, the find iter or find iterable will give me that actual specific instance. So I can actually print out what that m is as well. And we see that it's a match object. So if I ran, this same compile pattern dot match, it would give me, roughly the same thing as here. If I do the iterable, then I can actually go through every single match pattern that's in there, and I can see what those things are, which we can do by repeating this phone number. And that gives me all of this data, right? Which is really cool. It's really nice that I'm able to see all of that. And of course, I can also do .group and then the group name that I want. So region code, that actually gives me that specific group. And again, I named it that, so that's how it works. Now, if I try to use a index value, hey, what do you know? I actually still get that index value. So the index value is still related to the original index values for unnamed groups. Because that's what this is. These are unnamed groups. That's it. They're still groups, and they still have the same sort of idea here. And now group dictionary doesn't actually work in the same way with these unnamed groups, which we can actually test out real fast. I'll copy those unnamed groups here. And again, using the example that we've got here for this match pattern, we can try it out. The group pattern, right? So group dictionary doesn't come through at all. Now, the cool thing about having these group dictionaries then is, let's copy this last piece, is I can go ahead and say groups equals to, or let's call this datas actually. And then I can just append m.groupDict, comment these out. And then if I had pandas installed, which I do not, I can use this as a data frame and pass that in there. It would actually give me, the group values as column values as well. And of course, one other thing that you might actually want to have in here is the full number being m.group and 0. And then let's say, for instance, the data is m.groupDict. Or we can actually unpack that. Let's do something like this, just to make sure that I can even add the full number to the data. So data and full number equals to that full number. We'll print out what that data is and data. And there you go. So you now have a incredibly robust way to scrape phone numbers, and while you're scraping them, you can parse them into the name groups that you care about. Now, of course, you don't actually have to do those hand in hand, and in fact, you don't really need to do this at all. It's just more important to understand that you can use these groups as needed, because this kind of regular expression is now significantly more robust than the one we had before. However, the one before was incredibly easy. When I say the one before, I mean the one that we converted into these chunks anyway, right? So this right here almost encompasses everything that we just talked about, but it just doesn't have like incredibly specific things, or a really robust way to get all of the numbers themselves. So we would just need to change these chunks only slightly to get all of those numbers. So that's pretty cool. That is name groups and their advancing properties. Now I can hear you all going, well, what about letters? We've talked a lot about digits. How do we use regular expression for parsing letters? Well, going back to actual digits, remember, it's really easy. It's just /d. This is the same thing as saying 0 to 9. That will give me the exact same result. Letters aren't really any different. If we want lowercase letters, we can do from A to Z, or we can do capital A to Z. That will actually extract all of those capital letters. Now, similar to /d, if we do a plus here, that will give me the subgroups of these digits, or really repeating digits until they stop repeating. It's not really a regular expression group like we did above, but it's just a repeating digit over and over. You can do that same thing with letters as well. So if we do A to Z, repeating, we see all of the non-capitalized letters, right? So that's pretty simple, pretty easy to do. And also, if we wanted to include the capital letters, we would just say A to Z as well, and that now gives me literally all of the words that are in here. That is actually pretty easy, right? And if we wanted to include the numbers here, there is another shortcut pattern for doing that. Much like what we did with /d, there's another one called /w, and if we do that, that is literally every character, including numbers. So numbers and letters. So if we do plus here, then it actually gives me all of the groupings of numbers or letters, or really repeating patterns of either one of those things, not including punctuation. So how do we include punctuation? Well, if we come down here, let's go ahead and do the long form version of this, which would be 0 to 9, A to Z, A to Z. The ordering of each one of those things doesn't matter so much as the actual elements that are in there. So I want to include the punctuation. Well, what if we put a period in here? Well, nothing happens, or does it? Look at that. There's a period. It actually includes the period inside of that lookup. Now, of course, we could use groups like we did before, or different chunks for this particular pattern for that. But in this case, I'm not actually going to do that. I'll just leave it in there. What if you wanted to include spaces in these actual collections? What we start to see then, if you use spaces, is matching patterns that don't exactly make a whole lot of sense in this context. So this is actually where you would probably want to break this apart into different chunks like we did above. That is something I'll definitely let you handle on your own, because you should have the skills now. But if we actually get rid of this plus, what happens? Well, it actually breaks everything back down into the individual character, which is showing me the, spaces and all of that. Now, of course, if I recombined all these with a join call of these find all, it just brings back almost my entire string. Not quite my entire string, because it's still missing other characters, right? It's still missing the question mark as well as the slashes. Now, to use slashes, we just bring this in, whether it's a forward slash or a backslash. Let's actually just add in a backslash to this. So backslash, just so we can see it coming through. And of course, we get this, how cool is that ACK slash? It's no longer even registering that backslash itself. So perhaps as a string, we need to also actually escape a backslash, which is pretty common inside of Python strings anyway. So our regular expression pattern, on the other hand, well, how do we use this? Well, first and foremost, let's make sure we put an R here. If you don't put an R, there's going to be some issues happening, and we'll see that without the R. So first we would use a forward slash and a backslash, but of course the backslash needs to actually escape out the forward slash. It also needs to escape out the backslash. Now running it just as is, we get this unterminated character. This is because, of course, I didn't actually turn this string into a regular expression. Once I do that, then it actually will run this. And in this case, it actually brings in both backslashes, right? So if I get rid of one of those backslashes, the Python string itself is already ignoring those backslashes. So yeah, it's not perfect. I get that. But it is actually giving me the appropriate response for this string, right? So the string itself actually has both of those backslashes. So if I actually printed this thing out, what would happen is we would not see the double backslash any longer, or the escaped backslash, that is. Okay, so I'm still missing the question mark. So again, let's go ahead and put in a question mark here. Question mark shows up. Now, when in doubt, just put a backslash in front of it, and that will always escape whatever that value is, and it will give me an error if it is certainly not a valid escape method. Like if I did Z here, I would get this bad escape, right? That is true for special characters. Now, question mark itself is a special character, as we've already seen. It's an optional value. So in that case, I certainly want to make sure I am definitely, escaping it inside of my regular expression. Now, the only reason I'm bundling it all together in here is just to illustrate how all of these different characters and strings actually work inside of any given find all. The things that I'm doing in here can certainly be done in groups or chunks, just like we've done before, just replacing wherever the actual pattern matching part of that is, right? So just A to Z can do it, but also all of these characters as well. So that's pretty cool. Metacharacters are other features that Python regular expressions have. Metacharacters typically are things that we need to escape in our normal patterns. The first one being the actual caret. So what a caret does is we can actually search for the start of a string. Let's take a look at what I mean by that. So if I say pattern equals to the caret of capital A to capital Z, and let's go ahead and just use a regular expression in front of that, we can print out the re.findAll pattern of another one here, and then maybe we use that same general idea with yet another one here. And we run this, and what we see is, of course, the first one actually starts with a capital letter of A. Second one does not. It does not actually find the string that starts with a capital letter. Like this second one does not have a string that starts with that. No surprise there, but that's essentially how it works. Now, of course, if you didn't have that, you would see all of the capital letters, right? So A is a capital letter, O is a capital letter. Again, no huge surprise there, but it is nice to see that. Now, Django, if you're familiar with it, uses a RE path, which used to be called URL. This actually was always starting with that caret as a way to parse URLs, which is kind of cool. Now, even if you don't know Django, just know that this caret actually has a lot of practical use cases, because this right here is not incredibly practical in this sense. Now, carets have another meaning, which is what we see here, and that is the opposite of whatever a bracket pattern is, as long as it's in that bracket pattern. So let's say, for instance, we've got pattern equals to our, in this block with a caret of 0 to 9, right? So this is now saying match anything that's not a number, right? So literally matching anything that's not a number. Let me just grab an example here. Okay, and then we can just go ahead and do re.find all pattern and long example. So it pulls out everything that's not a number, where the opposite of that was literally everything that is a number, right? So just adding a caret inside of the brackets, it must be inside of the brackets in order for this to work. That is actually how you do the opposite of what is expected of the regular expression. And you can use it for letters or a combination of all those things as well. So if you literally just want special characters, so A to Z and punctuation, that's how you do it right there, right? So let's just throw in a random semicolon in there just to see that, yeah, it's pulling in the semicolons as well. So that's a cool way to extract all of the punctuation that's in there. And if I wanted to get rid of all the spaces, I could add a space there, and then what do you know? And I could also just turn this into unique items by doing list and set. Set will be the thing that actually turns it unique. And then there you have a really quick way to find all of the punctuation and special characters that are in here, which also includes, you know, all of these, right? Pretty cool. So now that we've got those two out of the way, the next thing is end of string. It works identical to this one, but it's just signifying the end. So pattern, and we'll go ahead and just say period $. I'm actually going to escape out in that period there. And again, I'll use that same long example, and we'll just go ahead and print out. I don't need the sit and list. We'll just run that, and we see that, yeah, it actually does end with a period, right? So if I didn't want to have a period, then, well, I wouldn't have to. And I actually could use this same regular expression pattern that we did above to find, well, what does it end with? What is the expression that's being ended on this particular sentence? You know, what does it end with? That's cool. That gives me, hey, is this a question? Maybe. So that's what the $sign does. And of course, if I actually wanted to find the $sign inside of one of these expressions, I would have to escape it. So if for some reason I'm like, hey, I'm just going to find the $sign value, right? Anything before a $sign. So let's actually see that in a string. So $. We've got $a here. So this actually is not correct. Let's do a $. And then there we go. Now we've got a matching pattern here. And again, the reason it's a colon is because this is literally anything that's not a character. Okay, or a letter or a number, that is. Okay. And then the other part, something that we didn't clarify, hopefully, that much, or I would imagine didn't clarify this that much. We're going to definitely come back to the plus and star in just a moment. Before we do that, we've got the question mark. We've already talked about this a lot, the optional value, right? So just a recap of that. If I want to say that a regular expression has an optional dash, then I can actually find all of the instances of that optional dash like I did before with those phone numbers. So definitely scroll back up if you want to see that. The pipe is a OR operator. That is something we saw above as well. So definitely scroll back for that. But that's really just where we did something like this, where it was, you know, ABC or 1, 2, 3. This is actually the pattern itself that would look for those two things, right? Or match those two things as a part of a chunk or a bigger, you know, pattern altogether. So now what we want to do is actually see those repeating patterns that we just didn't really cover a whole lot before. Okay. So let's go ahead and take a look. First off, we'll go ahead and say the pattern is equal to /w plus. So this, of course, is the same thing as saying 0 to 9 and A to Z, and then also A to Z. Okay. And then, well, a plus at the end as well. So we would just say that our example is, this is going to work, exclamation mark. Notice I do not have exclamation marks or any special characters in here. And then I would just do re.find all of that pattern and that example. And we get literally every item that's inside of this, right? Now, if I change this from a plus to a star, what this means is, well, it's going to give me a result if there's no actual pattern match. So it's going to give me an empty string if there's no actual pattern match versus no string, right? So what that means is if I run this, I now see that I actually have empty strings for where the spaces are, right? And if I actually had those spaces inside of that regular expression, it would then turn it into something just slightly different. But leaving it out, we now see that, hey, I can actually include the spaces as something that's missing in here. This actually gives you a better idea of what the length of this string essentially would be, or how many groups would be in here. I think more often than not, though, you're using the plus, where it's going to show when these things are actually being repeated. So another way to look at this is by not using a plus or a star and taking a look. And what we see here is each letter that's inside of this item. So each letter or anything that's matching this particular pattern is going to be laid out in a list like this. Adding a plus or a star is essentially going through each character. So this character is the next one a matching pattern to 0 to 9, A to Z, A to Z. And the answer is yes. And then you keep iterating that. This space does not match anything in either one of these patterns, so it's ignored. That's why we don't actually have those spaces. So that's an important distinction here. So essentially, the plus or star is saying repeat whatever is here, right? Let's actually see what I mean by the repeat whatever is here. I'll go and say AAA, BBB, and CCC. Okay. Well, I actually don't need AAA, BBB, CCC. I just need ABC in this manner. So I'm going to go ahead and now say AAA, BBB, CCC. Okay, so what is actually going to match here? That's the question that you need to ask yourself, is like, what of these letters are going to match? Just A, right? So it's looking for literally every single instance of one of these things that match. Now remember, this can just look for lowercase letters that are matching. That's all it's doing. So if I do AAA, it's not finding that. As soon as I add a capital A in here, it finds all of those things. But if I actually want to see the groupings of them, and I did something more like this, I can use the plus, and that will now turn those things into groupings, where this space right here actually breaks up the two groupings. That's all it's doing because it's not matched in this pattern. If I actually put that space in there and run it, now it is matched in that pattern, as well as the space right after it being matched in that pattern. Further, the other spaces are being matched as well, because of the rest of this stuff being matched too. So this space right here is, or rather, sorry, not that space, but this space matches this space. This space here matches this and this. Right, so and if we did star, we would get a lot more stuff because this doesn't match and this doesn't match, so it just gives me an empty string for each iteration of that, right? For each iteration that doesn't actually match. So that's repeating patterns, and those are some of those meta characters. Now, there are a number of things that we didn't necessarily cover because the Python documentation absolutely covers them in detail, but let's actually just really quickly talk about some of them. And I'm going to go ahead and use some markdown here for it. The first thing is /D. We've already done that. That's all digits, right? And then /D. This is matching any non-character digit, any non-digit character, which is the same thing as saying the caret 0 to 9, right? So the capital D version is, those are identical. Okay, so the next thing is /S, and this is any white space character. So I definitely want you to try out what a white space character is on your own. And then using a capital version of that is the opposite. So you'll see that a lot. And so the opposite of this is non-white space. And then we already saw the W. So /W is all the characters, which is the equivalent of 0 to 9, and A to Z, and A to Z, like that. And then a capital W is the opposite, like putting a caret in front of it. These are just shortcut methods to accomplishing the same sort of thing as this, right? So if you ever are in doubt with what one of these patterns actually means, definitely check out the regular expression documentation, because that will definitely clear up a lot of the things that you might have issue with when it comes to doing these regular expressions, and when it really comes to using these more complex patterns like we did above. So these last few ones were meant to be really highlighting some of the additional features that you might be using with regular expressions. But really what you want to do now is actually put these things into action and try and do it over and over. Thanks so much for watching. Hopefully you got a lot out of this. Now, what I would say is the biggest challenge you should take on now is how do you take everything you learned here and apply it to URLs? URLs as in this, right? Not only do you want to get the parts of the URL, as in the path and maybe any query parameters, you also want to get the domain, you want to get the subdomain, you also want to get the protocol, so HTTP, HTTPS, WebSockets, so WS, WSS. You want to grab all of those things and see if you can build your own parser based on everything we talked about here. I actually think you have enough of an understanding to be able to accomplish that, although it might be pretty challenging for you. And the best way to go about doing this first is to certainly understand how to parse phone numbers, at least doing it as close to as possible off the top of your head. Even if you use the reference a little bit, at least starting where you can extract the vast majority of these digits. And then eventually moving into named groups of each one of these digits as well. That is the challenge that I highly recommend you take on now to really solidify your understanding of regular expressions. But of course, when in doubt, come back to this guide because it's meant to help you in the future use regular expressions more. So thanks so much for watching, and I hope to see you next time.